Hey everyone, welcome back. I'm Greg the Vibe Coder. This is lesson 5.1, Blink an LED. And this one is different from everything we've done so far. HTML, Python, C#, WPF, all of that happened on a screen. This time your code is going to make something happen in the physical world, a real LED on your desk, blinking because you told it to. That feeling never gets old. Same 4 steps. Let's go. Before we do anything, you need 3 things. First, an Arduino board. An Uno or a Nano both work. You can get one from Amazon, eBay, or any electronics store. Usually somewhere between $5 and $15. If you search Arduino Starter Kit, you'll get the board plus everything else you need for a few dollars more. Second, an LED and a 220 ohm resistor. These almost always come in starter kits with the board. If yours didn't, they're a couple of dollars for a pack of 100. Third, the Arduino IDE, free software from arduino.cc. Download it, install it, plug your Arduino in via USB, and you're ready. If you don't have the hardware yet, no problem. I'm also going to show this in Tinkercad. It's a free browser-based circuit simulator. Go to tinkercad.com, sign in, and click Circuits. You can follow the whole lesson without a single physical component. If you've got the hardware or Tinkercad open, let's go. Step 1. Copy the prompt. Here's the prompt. Write an Arduino sketch that blinks an LED connected to pin 13 on and off every 1 second. Include comments explaining what setup and loop do, what pin mode means, and what digital write high and low mean. Keep the code simple and beginner-friendly. Short prompt, powerful result. I'm copying it now. Step 2. Paste into AI. New chat. Paste. Enter. The code you get back is called a sketch. That's just what Arduino calls a program. You'll notice it has 2 functions, setup and loop. Setup runs once when the board powers on. Loop runs forever, over and over until you unplug it. The AI will have commented all of that for you. Step 3. Run the code. I'm demonstrating this in Tinkercad. It's free, runs in your browser, and you can follow along without any hardware. If you do have the components, just mirror what you see on screen and wire it up the same way. Wire it up exactly as you see here. I'll keep the camera on the circuit while I build it so you can copy it. Once it's wired, click the Code button and switch to text mode. Select All, Delete, paste the AI code in, click Start Simulation. If you're following along with real hardware, the process is exactly the same. Wire it up to match what you see on the Tinkercad screen. The diagram on the lesson page shows you the exact connections. Then open Arduino IDE, go to Tools Arrow Board and select your Arduino model. Go to Tools Arrow Port and select the right port. Paste the same code in, click Upload and wait for Done Uploading. Everything you just saw in the simulation will happen on your actual board. That's your code, running on a chip, controlling electricity, blinking a light. One prompt did that. Step 4. Vibe Tweak. In the code, find the number 1000. That's the delay in milliseconds. 1000 milliseconds is 1 second. Change both instances to 200. Upload again or click Restart Simulation in Tinkercad. 5 times a second now. Same LED, same circuit. One number changed. Try 50, try 2000. Try making the on-time and off-time different values. You're in control. Extra credit. If you want to go further, paste this. Update the Arduino blink sketch to blink an SOS pattern in Morse code on pin 13. 3 short blinks, 3 long blinks, 3 short blinks. Then pause for 2 seconds and repeat. SOS in Morse code. The same signal that's been used for over 100 years, now running on your Arduino or your Tinkercad simulation. You'll see exactly how timing works to create rhythm in code. Reflection. Before you move on, think about this. Your code just made something happen in the physical world or in a simulation of the physical world. Either way, the logic is identical. Can you find the line that turns the LED on? It's one word, high. That's all it takes. That's Lesson 5.1 done. Next up is Lesson 5.2, read a button. Press a button, the light turns on. Release it, the light turns off. Input meets output, and that's when Arduino really starts to click. Links to everything are below. Hit subscribe so you don't miss it. See you in 5.2.